Okay, so the next one talks about multiplying polynomials. So, or in this case, binomials. This would be a monomial. Two of them would be a binomial. So, we've done this before where you use a table as an aid. I believe in Module 1 they actually showed you this. So, when you're using the table as an aid, you're going to write out your binomial. So right here it says fill out the table with the partial to identify the product. So this would be 1, and this would be your other binomial that you're multiplying together. So you write out a chart like this where x plus 5 is right here, x plus 2 is right here, and then just fill it out. So x times x is x squared, 5 times x is 5x, 2 times x is 2x, and 5 times 2 is 10. And then all you have to do is combine like terms. So x squared, there's not another one that has x squared. That is the only term that way. So it's x squared. Now 2x and 5x, they both have like terms. X is to the first power. Maybe like x to the first. So we can add them together. So that's going to be plus 2x plus 7x. And the last one is going to be 10. For this case, they're all positive, so these stay positive. This has been a negative, and this would be negative values over here. But it's all positive, so it'd be 10. So then to finish it, just be x squared plus 9x, add these two together, plus 10. So that's one way to do it. The other way is without the table. This way, you're using your distributive property. So you're distributing x into each one of those, and then you're going to distribute y into each one of them. This is a little bit quicker, a little easier, I think, to do it on the fly, but either way is fine. So with this one, if you were to distribute it, you'd have x plus y, x minus 5, and so they show the arrows, so it'd be x times x times 5, so you're effectively doing this. And then y times this. So you still have the plus sign because there's a plus between them. Y times x minus 5. And then you just distribute in. The other way you can think of this is FOIL. And so the way that FOIL works, it's first, outside, inside, last. So you have FOIL over here on the side. But with FOIL, you're using the distributive property. So you just do the first, so the first of each one of them, the outside, so this would be the outside, inside, multiply them together, and then last, the last one of each one of them. Either way works, just make sure that you write them out correctly. So you get, if we were to finish this one down here, I'm just going to write it up here on the side, x squared minus 5x, and this one's going to be plus y times x minus 5y. For this one, there's nothing you can combine. You would just leave it like this. Okay, so it's going to introduce a couple things here. The first one it talks about is difference of squares. So difference of squares is where you get nothing in the middle. Normally when we are multiplying binomials, we'll get something here plus something here plus something here. Normally that's what you're going to see. If you're missing something in the middle, you may have done something wrong, or it could be a difference of squares. So for a difference of squares, you're going to notice they're the exact same. This is x, 2, x, or 2 and x, but the difference is this right here, the sign. On difference of squares, one of them will be plus the second value, and one will be minus the second value. So it'll end up looking like this. You have x plus 2, and then x minus 2. So when you complete the table, you're going to get x squared, 2x, and you get x times the negative 2, so negative 2x minus 4. So what will happen is you'll have x squared, and then it'll be plus 2x minus 4. Well, 2x minus 2x is going to be 0. So they end up canceling out. And then you're just left with x squared minus 4. And that would be all that you get there. So without a table, if you're going to factor it out using FOIL, this is kind of how I do it first. So you do the first, so it'd be x squared. You do outside, so that's going to be minus 2x. Inside, so that's plus 2x, and then last, that's going to be minus 4. 2 times negative 2 is negative 4. So then you just look here, negative 2x plus 2x, those are going to cancel, and you should be left with x squared minus 4. So when we're working here on exercise 4, I'll give you a couple examples and work with you on a couple of them, but then I'll let you work on it on your own. So this one, factor the following examples of the difference of perfect squares. So these you're going to be factoring, and they're going to look somewhat like this. So for this one here, with your first value, you can always split it up. So t will just go into each one. T. Okay. So then this next one, it's going to be a perfect square. So 25, what is the square root of 25? Do 25 square root, that's going to equal 5. So we'll have plus and minus, and then we'll take the square root of 25 and put 5 in there. So if we were to go through and multiply this, it'd be t plus 5, t minus 5. You get t squared, that's going to be plus, so you'll do the outside, minus 5t. I'll put a little lip here on the bottom so you know which one's a t and which one's a plus. And then this one here, it's going to be inside, so 5 times t plus 5t, and then outside, or last, minus 25. So these two will cancel, and you'll be stuck with t squared minus 25. So the next couple ones are a little trickier, but I want you to go ahead, try and practice them on your own, see if you can figure them out. Okay, so when you're working on the next one, something I didn't necessarily tell you, when you're working on these, you're going to take the square root of this front and the back side number. So for this one, if we were to take the square root of 4, that's going to equal 2. If we did x squared and we found the square root of that, that would equal x. So for our parentheses, you're going to put 2x. You're going to multiply them together again. That will be your first term. The next one, the square root of 9 is going to be 3. So we put a 3 in each one. And then we'd have to put in, one would be a positive, one would be a negative. It doesn't matter which one you do. You just have to make sure that you're alternating that. So that'll end up canceling out the middle term, and that would work. So if we did the square root of 16, we're going to get 4. So 4 would be the first term. But we also need to do the square root of h squared. So h squared, the square root of that is h. So then we'll square root both of these. We can do it individually just to keep it simple. So square root of 36 is 6. Square root of k squared is just k. So one of them needs to be positive, one of them needs to be negative. Okay, the last one, so 4, we're going to end up squaring, or taking the square root of that. It's going to be 2. Square root of b squared is b. And then one has to be positive, one has to be negative. So that would be how you get the answer on those ones. And then there are actually a couple other ones, E and F, that we'll finish together. So x to the 4th, if you take the square root of x to the 4th, that's going to equal x squared. Because if you do x squared times x squared, that would equal x to the 4th. Because it ended up being x times x, which would be this breakdown, times x, and that would equal x to the 4th. So we'll have x squared, that'll be the first one, and the square root of 4 is going to be 4. So we'll put them on the back side. One has to be plus 4, one has to be minus 4. Okay, the next one, x to the 6, square root of that is going to be x to the third, because that'd be x to the third times x to the third. If you were to multiply by itself, you get x to the 6th. And it's the same breakdown as up here. So x to the third, x to the third. And then we'll take the square root of 25. So the square root of 25 is going to be 5. And then one has to be a positive, one has to be a negative. So right here, write a general rule for finding the difference of squares. So generally, if we have it written like this, a squared minus b squared, which this is what we have up here, a would be x squared. We square that, it's x to the 4th, minus b squared. B would end up being 2. Sorry, wrote that incorrectly. So b would end up being 2, b squared is going to be 4. So when we're writing out the factored version of this, it would be a plus b, a minus b. And that would be how we write out a difference of squares. Difference of squares is something that you will need to know going forward. I know that this will be used in Algebra 2, and it's really helpful for helping you to solve. I could also see us using it as well to solve quadratic equations. Okay, so this again will be a little bit more practice for you. I'll walk you through on a couple, but really for this one, it's all going to be on you. So take your time, practice this, and then come. Okay, so I just ended up writing out the answers here. When you break this one down, you're going to get 3y plus 10z and 3y minus 10z. And that's because you're going to take the square root of this one and the square root of this, and you'll end up breaking them down. So this one, you take the square root of a to the 4th, it's going to be a squared, square root of b to the 6th, b to the 3rd, and then you'll just have your opposite sides. So this one down here is a little interesting because it'll actually end up factoring twice. So when we take the square root of r to the 4th, you're going to get r squared, so that's fine. Square root of 16 is 4, and the square root of s to the 4th is s squared. This one right here will factor down again because it's exactly the same situation as up here. So we just leave r squared plus 4s squared. We leave that over here, but then we can also break this down again. So the square root of r squared is going to be r. The square root of 4 is 2. So we'll put that on each side, and the square root of s is going to be s, or s squared is going to be s. And then we just have to put a plus and a minus. And so this would be the correct version. You should be factoring it down twice. It's just kind of something to pay attention for. It'll only be with these ones too. You can't get a difference of squares with this kind of a problem, but this one you can.